Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary plane regarding the evaluation of the true shape and size of the inclined section surface of a solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a solid which has been sectioned by an inclined plane. So this is the top section surface of the solid which is inclined one. Now we are required to evaluate the true shape of this inclined section surface of the solid. So let us read out the statement. Draw the complete auxiliary view and also find the true size and shape of the inclined face as it is available in the figure which is given below. So we can see that this is a solid which has been cut by an inclined plane and we are left with an inclined section surface at the top of this particular solid. Now we need to evaluate the orthographic projections of the solid in such a way that we should be able to obtain the edge view of this section surface in one of the orthographic views. So we can check out over here that we will be getting this edge view of the section top surface of the solid in the left hand side view, because in the left hand side view this entire surface, it will be visible to the observer as an edge view, and besides the left side view we are also going to draw the front view of the solid, and then by using the information available with us through the left side view and the front view, we are going to draw an auxiliary inclined plane which will be parallel to the sectioned inclined cut surface. And once we have this auxiliary plane drawn parallel to the section cut surface, so the projections of all of these points which are lying on the top surface of this cut section surface over here, so these projections onto the auxiliary plane, they will provide us with the true shape of this cut inclined section surface over there. So let us proceed with the construction of the orthographic projections of the solid. So in order to draw the orthographic projections of the solid, so we have to draw first of all the XY reference line, and since the two views which we are going to draw, they will be front view, so front view will be drawn onto this side and left side view will be drawn on the right hand side of the front view of the solid. So we are going to have one X1 Y1 reference line drawn over here as well, so that on this side we will be drawing the front view of the solid, and here we are going to draw the left hand side view on the right side of the front view projection. Now in order to draw the front view projections, we know that the two dimensions will be required. This is the side of the front view. Okay, so this is the side through which we are going to look at the solid from the front. So from the front we observe that the width of the solid happens to be 56 millimeter. So this width of the solid we are going to draw over here. So these two projection lines we have drawn which are at a distance of 56 millimeter. So this is the width of the solid that we have drawn in the front view, and besides width we are going to require the height of the solid. The height of the solid happens to be 65 millimeter. So this is the height of the solid available with us from the isometric projection of this given solid. So we have drawn this height of the front view projection over here as 65 millimeter. So this completes the outline for the front view projection which we have to draw over here. Similarly, for the left hand side view, we evaluate that when we are going to look at the solid from the left hand side. So this is the depth of the solid. So the depth of the solid happens to be equal to 70 millimeter. So we have got depth of the solid equal to 70 millimeter from the left hand side view, and the height of the solid will be equal to 65 millimeter. So this 65 millimeter height we had already drawn in the front view. So this we have carried forward or extended onto the left hand side view. Now we have drawn these two projection lines where the distance between these two projection lines will be 70 millimeter. And since we are given that the edge, this edge width over here, this happens to be 25 millimeter, and this edge width over here, this will be equal to 45 millimeter. So we have marked these edge widths along the left hand side view as 25 millimeter and 45 millimeter. And another thing we also know from the side view that there is a sectioned inclined surface over here, and the front corner of this particular inclined cut surface, it is at a height of 30 millimeter from the bottom. So we can check the front section of this inclined cut section happens to lie at a height of 30 millimeter from the bottom. So we have drawn this 30 millimeter from the bottom, and this is the front side over here. And now on the rear side, that is the back side, the height of this inclined cut section is 65 millimeter. So as we are going to obtain the edge view of this particular cut section in the left hand side view, we observe that this rear portion which is lying at the back end, which is going to start from the rear end of the solid, it is at a height of 65 millimeter. So we can check here the height, it is equal to 65 millimeter, whereas on the front side, this inclined section surface edge view, the second end of that, it will be lying at a height of 30 millimeter from the base. So this way the edge view has been obtained. Now we also know that this is the edge height over here. Now this edge height is not given to us, so this will be corresponding to whatever distance of this edge height we get corresponding to this depth of 25 millimeter from the rear end of the solid or 45 millimeter from the front end of the solid. So I can draw a vertical edge over here. So this edge height, this is obtained as per the construction, because this value or the dimension is not provided to us. So this way we will be able to locate this point or this point over here, right? So the height of this point will be determined as per the construction, because we know that this edge or this edge, they are lying at a distance of 25 millimeter from the rear end of the solid or 45 millimeter from the front end of the solid. So this is 45 millimeter from the front end of the solid and 25 millimeter from the rear side of the solid. So this completes the construction of the left hand side view. Now having obtained this point over here, now I can project this point in the front view. So I will be projecting this point in the front view over here. Similarly, I have also obtained these edges over here. Point 4 and point 5, they have been obtained over here as an edge view in the left side view. So here I had obtained points 2, 3, 6 and 7. So 4 points we had obtained over here in the left hand side view. These points are 2, 3, 6 and 7. Now these points, they will be obtained along this horizontal projector line over here. Similarly, I have been able to obtain the points 4 and point 5 over here, because the edge view is visible to me in the left hand side view. So the projections of point 4 and 5, so they will be coinciding over here. Now once I have obtained these 2 points as an edge view over here, now I am going to project this on the left hand side onto the front view. So having obtained this height and this height in the front view, so what I have been able to obtain? I have been able to obtain this height, right? So once I obtain this height, this is the height. So I will be able to obtain points 7, 6, 3 and 2 over here onto this line. Similarly, I have been able to obtain this height equal to 30 millimeter. And once I have drawn a locus line at a height of 30 millimeter, I will be able to locate points 4 and 5 onto this particular projector line over here. Now another thing we know that once we look at the solid from the front, now we find that this edge width over here, this is the width of the solid. So this edge width happens to be 15 millimeter, whereas this edge width happens to be 26 millimeter. And further, through symmetry, this is also equal to 15 millimeter, because the total width is equal to 56. So here you have 26 width for this section and 15 millimeter width is given for this section. So 15 plus 26 gives me 41. So the total width of the solid happens to be 56. So it means that there is a symmetric cross section over here. So this will be a rectangular cross section which will be mirroring 15 millimeter will be the width, and the height, this height will be as per construction over here. Now I am going to mark the widths over here, 15 millimeter from this end, 15 millimeter from this end. So the intermediate width will be equal to 26 millimeter. So now you can check from the rear end, we have marked 15 millimeter width corresponding to this section over here, this face of the solid, this vertical face. Now from the other side, again I have marked a width of 15 millimeter, and then the intermediate section which I am going to have over here, this width will be equal to 26 millimeter. So this is a rectangular surface having width equal to 26 millimeter and height is equal to 30 millimeter. So this way the front view projections of the solid, they have also been completed. Now I am going to carry out the darkening of the edges which are visible to the observer. So now we can observe that this is the T section, which is an inclined cut section which has been cut by an auxiliary face at the top of the solid. Now we can check, this is quite a big surface over here. So this bigger surface, it appears to be relatively much smaller projection onto the front view. The reason is because of its inclination with respect to the vertical plane. So since this inclined surface happens to be inclined to the vertical plane, therefore we are going to get the foreshortened or a reduced projection of this particular surface in the front view, that is onto the vertical plane. Now second, we have got this vertical face over here. So this vertical face happens to be parallel to the vertical plane. So the projection of this rectangular surface onto the vertical plane will represent its true length. This surface is also true length because this surface is again parallel to the vertical plane. And finally, this surface, it also happens to be parallel to the vertical plane. So we are able to obtain the true shape of this surface onto the vertical plane, right? So this way, this is true shape, this is true shape, and this surface is also true shape. So now we are left with this T cross section, which is an apparent shape or a foreshortened projection of this T-shaped section surface which is lying on the top of the solid. Now while we are going to look at this solid from the left hand side view, so we observe that this is the edge view, and corresponding to this edge we have got this projection, corresponding to this edge we have got this projection, so corresponding to this edge we have got this projection. Now we have been able to obtain the edge view, we have been able to obtain the shortened view over here in the front view. Now using the fundamentals of the auxiliary planes, we are going to develop the true shape projections of this particular sectioned inclined surface which is lying at the top of the solid over here. Now let us do the marking of all these points. These points I had shown in the construction over here. So I am going to start from this point. So this is 1 dash, this is 2 dash, this is 3 dash, this point is 4 dash, this point is 5 dash, this is 6 dash, 7 dash and 8 dash. So we can see 1, 2, 3, 4, 5, 6, 7, 8. So we required 8 points to define this T-shaped cross section over here. So these points, they have been appropriately marked in the front view, and in the left hand side view the projections, they will be represented as double dash point. So once we are going to look from this side, you see, once I am going to look from this side, so the projection on the edge view will be 8 double dash 1 double dash. So I can mark over here 8 double dash 1 double dash. Once I am going to look at the solid from the left hand side, so this point will be 7 double dash 6 double dash 3 double dash and 2 double dash, 7 double dash 6 double dash 3 double dash and 2 double dash. And finally, when I am going to look at the solid from this end, 5 double dash and 4 double dash will be obtained over here. Now I am going to draw an auxiliary plane which will be parallel to this edge view of the inclined section surface. Now having obtained this auxiliary plane, parallel to this surface. Now what I am going to do, I am going to draw projectors through all of these points, and these projector lines, they will be perpendicular onto this AIP. All these projectors that we have drawn through these 8 points which were lying onto the edge view of the inclined section cut surface. So these projector lines, they will be perpendicular to the plane, that is x2, y2. Now I need to plot the distances of these points from the x1, y1 reference plane. So whatever are the distances of these points, that is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash. So whatever are the distances of all these points in elevation which are lying on this section cut surface from this profile plane, that is x1, y1. So all these distances, they will be marked in front of this auxiliary plane. Now this distance, you see, we had drawn this distance to be an arbitrary distance over here. So we did not measure this distance because this was not given to us. So what we are going to do, I have marked this distance as distance x. So whatever is the distance of points 1 dash and 2 dash from this profile plane x1, y1, so we have marked this distance is equal to distance x. So this distance now I am going to plot ahead of the plane which is x2, y2. So having marked this distance, what I can do, I will be drawing a projector line over here which will be parallel to the plane x2, y2. The reason is because this line, this edge, it is parallel to the plane x1, y1, and points 1 dash and points 2 dash, they are lying at an equal distance from the profile plane, that is distance is x. So once I have drawn this projection line over here, now corresponding to the projection of 1 double dash and corresponding to the projection of point 2 double dash, onto this line I will be obtaining the projection as 1 1 dash over here. So the name of this point will be 1 1 dash, and the name of the point which will be obtained over here, this will be 2 1 dash over here. So these 2 points I have obtained in the auxiliary elevation view over here, which will give me the true shape of this T-shaped surface over here. So the 2 points I have been able to obtain, that is corresponding to this distance x over here. Next, I know that the total width of the solid happens to be how much? 56 millimeter. So this was distance x. So ahead of distance x, I need to move another 56 millimeter so that I can obtain this end of the solid over here. So that I can obtain this end of the solid. Earlier I had obtained this end of the solid. Now I have obtained this end of the solid over here. Now once I draw this 56 millimeter corresponding to this distance over here, now the coordinates of points 8 and 7 will be located in the same line where points 1 and 2 they were lying over here. Now once I have obtained this projection line, so we observe that onto this projection line I am able to obtain the point 8 1 dash corresponding to the distance x plus 56. So this point will be obtained as 8 1 dash. Why? Because this was the distance x, this is the distance 56. So 56 plus x distance gives me the location of 8 dash point. So once I transfer this distance in this direction over here onto this projection line, why? Because the point 8 double dash, it is corresponding to this particular projection line. So once I obtain this horizontal line, I'll be able to obtain this point as 8 1 dash over here. Similarly, I have got point 7 double dash over here. Now point 7 dash, it is also located at a distance of 56 plus x distance from this x1 y1 profile plane. Now here I have got the projection line corresponding to 7 double dash. So if I move along this projection line, this is distance x plus 56. So this will give me the location of the point 7 1 dash over here. Now having located the first edge, having located the second edge, now these 2 remaining edges I need to create over here. So this edge will be at a distance of another 15 millimeter beyond the distance x, and this edge I can obtain at a distance of either 26 millimeter from this end or 15 millimeter from this end over here. So let me create these two edges in the auxiliary inclined plane over here. Now I have got this total width of the solid equal to 56 millimeter. So within this 56 I have got three components, 15 plus 26 plus 15. So once I mark these three distances corresponding to the three distances over here, 15, 26 and 15 over here. So two projectile lines I'll be able to draw. The moment I draw these two projectile lines, now I will be able to locate this point will be point 31 dash, this point will be point 41 dash, this point will be point 51 dash, and this point will be point 61 dash. Now please check, this is the point 31 dash and 41 dash. So the location of point 3 dash and 4 dash from the profile plane will be 15 plus x. 3 dash 15 plus x over here. So here onto the locus line of 3 double dash, as I am moving, this distance is x and this is 15. So this is the location of 3 1 dash. Similarly, this is the location of 4 1 dash, that is at a distance of 15 plus x, and this will be lying where the edge view corresponding to the point 4 double dash was lying. Next we have got another 2 points over here, 5 1 dash and 6 1 dash. So we know that the distance of 5 dash and 6 dash from the profile plane, they are x plus 41 millimeter, x plus 41. So 6 is also located at a distance of x plus 41. So here along the projection line corresponding to the point 6 double dash, as I am moving, this distance is x, this is 15 and this is 26. So this makes it 41 plus x over here. So this is also 41 plus x. So here I locate 5 1 dash and 6 1 dash points over here. So this way all the 8 points of the section cut portion which is inclined, they have been located in the auxiliary inclined plane. And once I darken the edge views corresponding to all these points, so I will be able to obtain the true shape of this particular solid in the auxiliary plane projection view over here. So this way, this is the true shape of the cut section, and we can compare it with the apparent shape which we had obtained in the front view. So we observe that the apparent shape which was obtained in the front view, it is much shorter than the true shape of this solid. This is because we were having this edge view which was inclined to the vertical plane over here. So we were not able to get the true projections of this particular section cut surface onto the plane of projection over here. So I hope that through this discussion you would have understood the procedure, that how do we evaluate the true shape of an inclined cut surface with respect to any given reference plane using the auxiliary plane method. So this is all for today. So we will be continuing with further discussion on few more cases regarding the evaluation of the true shapes of the cut sections which have been cut by auxiliary planes. So thank you very much. Thanks a lot.